Hello, welcome to Lesson 14, the converse of the Pythagorean Theorem. Before we begin today's lesson, let's look at our key vocabulary words. Converse of the Pythagorean Theorem. If the lengths of the sides of a triangle satisfy the equation a squared plus b squared equals c squared, then it is a right triangle. Pythagorean triple. If any set of three integers, a, b, c, satisfy the equation a squared plus b squared equals c squared, the triangle is a right triangle. So sometimes you are going to be asked to determine if the side lengths would form a right triangle. And in order to check that, you would use the Pythagorean theorem, a squared plus b squared equals c squared equation, this simple little formula. And what we would do is we would plug in our values and we would see if the equation equals each other, if the left side equals the right-hand side. And remember, in a right triangle, you're given A, B, and C. The hypotenuse, the side across from the right angle, is always your largest side length. So what we're going to do today is we're going to plug in our given numbers and we're going to see if each one of these examples would form a right triangle, okay? So 9, 12, and 15, you have to ask yourself which one would be our hypotenuse. And of course it would be the largest. So we would plug in 9 squared plus 12 squared equals 15 squared, okay? And in this example, they happen to be in order from least to greatest. Always be careful to check that though, okay? The largest number would be by itself. It's plugged in for the value of C. So let's check it. 9 squared is simply 81. 12 squared is 144. And 15 squared, sometimes we don't always have these memorized, is 225. So our job is to see if the left-hand side of the equation equals the right-hand side. So is 81 plus 144 equal to 225? And yes, it is. So when your left-hand side matches your right-hand side, it would be a right triangle, okay? So yes, these side lengths, 9, 12, and 15, would form a right triangle, okay? So hopefully that made sense to you. All right, let's look at our second example. We have 25, 16, and 9. You have to ask yourself which one is the largest side length, and it would be 25. So 25 would be left alone on the equation, in the equation. And then we would plug in 9 squared plus 16 squared. And we're going to see if our left-hand side equals our right-hand side. So 9 squared is easy. We have that one memorized, 81. 16 squared is 256. And 25 squared, 25 times 25, is 625. So we're going to see if our left matches our right. And I can already tell that 81 plus 256 is way less than 625. But we'll go ahead and add them up. 256 and 81 only comes to 337. And that does not equal 625. So our answer would be no. These side lengths, 25, 16, and 9, would not form a right triangle. All right? So sometimes they'll ask you if these numbers would create a Pythagorean triple. And that simply means, can you plug them in to this equation and get the same number on the left as you get on the right? So the converse and Pythagorean triple are the same thing, okay? So let's look at our third example, 8, 8, and 11. Which one would be your hypotenuse? Well, it would be 11. So 11 needs to be alone on one side of the equal sign, okay? So a squared plus b squared equals c squared. Well, I know that 8 times 8 is 64. 11 times 11 is 121. Is this going to match 121? Is it going to be equal to it? Well, I can tell that this is 128. And 128 does not equal 121. So our answer would be no. 8, 8, and 11 would not form the sides of a right triangle. So far, so good. All right, we have 3 more examples. 24, 51, and 45. Which one is your largest number? Well, it would be 51. So 51 would be our C value. That's our hypotenuse. And then we would plug in 24 squared plus 51 squared. Oh, I'm sorry. Plus 24 squared plus 45 squared is equal to 51 squared. So we're going to use our calculator. 24 squared is 576. 45 squared is 2,025. Ooh. And 51 squared is 2601, 2,601. So, is our left-hand side going to equal our right-hand side? So we'll do the math. 576 plus 2,025 equals 2,601. So our answer would be yes. Those side lengths would form a right triangle. Okay, so let's keep on going. We have 2 more examples. By now, I'm sure you know the routine, and I hope you're following along. But we'll go ahead and do the last 2, just for extra practice. 8, 17, 15. So we have 8 squared plus 15 squared is equal to 17 squared. Again, we have 64. Okay, 8 times 8 is 64. 15 squared is 225. And 17 squared, 17 times 17, is 289. Now, is our left-hand side going to equal our right-hand side? Well, let's do the math. 64 plus 225 is 289. Is 289 equal to 289? Yes. So, what that means is these side lengths, 8, 17, and 15, would form a right triangle. All right, our last example, 5 squared plus 7 squared equals 9 squared. All right, so we have some small numbers. We all know our multiplication tables, so those would not be hard to do. 5 times 5 is 25, 7 times 7 is 49, 9 times 9 is 81. Is 25 plus 49 equal to 81? And no, it is not. So since 74 is not equal to 81, those side lengths would not form a right triangle. So I hope you're walking away from lesson 14 knowing what the converse of the Pythagorean theorem means. I'll see you in the next lesson.